Okay. So we can start with what we studied a little bit in this chapter about streaming systems and what are the three different type of streaming systems that we saw. One was direct messaging, other one was message broker, and in message broker there was another one which had event logs. So after that, in the second section where we started databases and like event sourcing and event sourcing and change data capture, all these systems were all based on event logs. So how data capture helps us in keeping multiple systems in sync, and then how these logs are compacted, how we take snapshots. These are the things that we discussed. And then how can we derive a certain state from the event logs. Like for example, you can have like multiple systems. One is change data capture, another one would be something else where, for example, you have a application where your data goes in database, but also you want to provide certain analytics like how your application is doing in terms of usage. So in certain cases, you would want to have the data in just one place and deriving multiple uh, information from it. So that's what we saw in event sourcing. Apart from that, we studied what is commands and events. So by definition, commands are user requests, and event is when that request is completed. So the example that was given is seat reservation. When user clicks on reserve, then it is a command. When the command is validated, then it becomes an event, and all the consumers, they can validate the event, and then only seat reservation happens. So in seat reservation system, generally user first receives okay, your seat is blocked, and then there is a second confirmation. So it's a split step, and that validation takes place between the consumers, and then you can confirm, okay, now this is an event where the seat reservation is being completed. So that was commands and events. After that, we
So are
also
you
saw.
sharing the screen? Okay.
I'm not sharing screen because it's just a revision of what we studied.
Okay. 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 Sure. Go ahead.
Yeah, and then we talked about like state. If you want, I can share my screen. That's not a problem.
No, doesn't make a difference. You can carry on.
So then we talked about how the state is different in terms of, for example, in event logs, everything is there. All the logs are there. The entire history of what user did is there, right? And now if you want to find out what exactly is the current state of application, you can find out through that logs. Okay, user did, for example, user added something in the cart, user deleted something from the cart, user added another item from the cart. All these information, these are truth, basically what user did. So we keep those information, and that can, when these information is integrated, kept together, defines the state of the application. So that's one way of expressing the state of data, or we can express the state in terms of event logs, like what is the state currently of anything in terms of event log. And the second thing is how data is changing with time. That is second way of expressing the state of the data. So these are the two relationship between the application state and event log that we are seeing. So you can integrate the event log and you get the application state. And second is how the event stream is changing with time, and then you are seeing changes in the application. Okay. And then we discussed about the advantages of immutable events. Like you can, if there is a buggy code, your data will not be impacted. Uh, and events are helpful in finding, what user did, and you can recommend on similar kind of items if user has not bought them yet. So something like that. These are the advantages of immutable events. Then we talked about like several views that can be derived from the event log. So there are different systems, and all have to be in sync. And the good thing would be like, if you don't have data which has a schema, For example, you need, if you want to get the health of your application, you can get it through event logs, right? And then you need to know the usage of your application. That's something you don't need right now, but you would want to know it like later in some time. So you can just have one set of event logs, and you can derive these multiple information from these event logs. So that is deriving these different views from the same event log. So the advantage of it would be, for example, if you have something new, you had some old system and now you have to bring something new, and then you think about, okay, like how can I change the schema? Like, because since in event log there is no schema, you don't have to worry about those things, and you can create your new system and extract the data in the way you want it to be, and then you can just deprecate the old system. So that's the advantage of keeping that raw event logs, that you can use it like like in a new system or whatever, right? Because you are not dependent on, migration and like create, like having a different database, or dependent on schema and stuff like that. So, and then we studied about limitation of immutability, because event logs, we are not changing it. It is not suggested to change it. We want to keep that history. So the disadvantage that we studied was that the size of the data obviously will be really large. And second is, in cases of like GDPR, like privacy issues, that data needs to be deleted. But since it's immutable, how can we delete it? So that was the limitation. Now, what Abhishek will be talking about today will be processing streams, and I hand over it to Abhishek. Uh, if anyone has any question before Abhishek starts, we can discuss about it.
Okay, thank you so much, Shreya. Um, yeah, so now let me share my screen and I'll give a brief overview of what we're going to discuss today in processing streams, and then I'll discuss these topics one by one. So basically, like this entire chapter, we can divide into three parts, right? This stream processing, we can divide it into three parts. So those three parts are like this, that we have a source of stream, right? And that source, the example of that source of stream is like some user activity events or some data from some sensors, or whenever you make a write to a database, each write event could be considered as an event, right? So these all these events are your source from which your stream is generated. Now, once you have the source of stream, you want to transport that stream. So by transporting, you want the stream to be moved from one place to another, right? And there are three ways we saw how to transport it: uh, direct messaging, via message broker, and via event logs, right? And the analogy that I have in my mind for transporting these streams is, so let's say you have to transport a message from one place to another, you have to transport a mail from one place to another. So there are three options. Either you directly send that mail. So if you have to send that mail to your friend, you directly send that mail to your friend, right? That is similar to direct messaging. Second option is you use a message broker. You use a service like USPS, where they will keep your message with them, and now they will eventually deliver your mail or your message, right? The third system is event logs, where the analogy would be that all your messages are kept in one store in one place and they are never deleted. Anyone who wants to view your message, they will come to the store and look at the messages, and then they can look at the messages, but these messages are never deleted, right? So these message brokers typically would store your messages in a buffer in memory, and they will delete once the messages are delivered. Whereas this event log is what Apache Kafka kind of systems are, where they keep your messages in the store and they never delete it, right? And so these were the three systems of transporting. Now, once you have transported the streams, now you would want to do something with your stream, right? You would want to process your stream. So there are three main things why you would want to process your stream. Like one is that you are building a secondary storage system out of your stream, right? So basically, I had a source of data. I had a primary source of data. From that primary source of data, whenever any update was made to that data, I have created the events, and those events are propagated to the secondary storage system, right? So that's the case when we process the stream to update our secondary storage system, right? Um, and the examples of secondary storage systems are like if you have some cache or if you have some search index or things like that, right? The second way to process your streams would be notifications, that once your streams are received, they are then sent as notifications to users, right? You can send either emails or push notifications, right? Or the other way to process your stream, the third way would be that you are building derived streams. So possibly you have one or more input streams, and then you are producing one or more output streams, right? So that is the third way uh, of using your stream and processing your stream, right? So now, like mainly, we will be focusing on how we can build this derived streams, that you process one or more streams and then create output streams, right? So basically, now let me give you overview of what we're going to discuss. First, we are going to discuss what are the uses of stream processing, why at first place we want to process these streams and create these derived streams out of it, right? So the uses are like monitoring, or if you want to build a complex event processing system, or it could be you're using it for stream analytics, or you're using it to create a materialized view, or you could be using it to do a search on the streams, right? So these uses we will discuss in more detail one by one. Once we are done with that, then we will be discussing about reasoning about time. So the main topic in this is that when we are doing any stream processing, uh, we have to think about how we are uh, reasoning about the time, in the sense that are we going to consider the time when the event happened or the time when we are processing that event. Those two things are different. If we take event time, it has some advantages and disadvantages. If we take time when we were processing the event, if we are taking that timestamps, it has some advantages and disadvantages. So we will discuss more about that. Then we will discuss how to join streams and what are the various ways to join the streams. And then finally, we will end the chapter with the fault tolerance, that whenever we are doing any processing with the streams, if anything fails, if our processor fails, how do we tolerate faults in our streams? And as we will see, it's not so easy to tolerate faults with the streams, because these are infinite. So streams are infinite sources of data. So just rerunning your job, in case of failures, we usually rerun, right? But here you have infinite amounts of data that you have been processing from long time. So simply rerunning would not be sufficient. We would have to do something smart to deal with these faults, right? Okay. So now let's move to this section of uses of stream processing. Uh, so one of the uh, very important uses of stream processing is monitoring, right? So, like, so basically, let's say you have a stream of credit card transactions and you want to detect any fraud, right? So basically, you want to detect that if this transaction seems to be a fraud transaction, right? So then you will be processing the streams continuously and monitoring for frauds, right? Another example is that in the trading system, so generally uh, people would uh, create some rules that whenever the value of this stock drops below a particular value, then it should execute the trade, then it should actually sell the stock, right? Because they don't want to bear a big loss. So whenever a stock has fallen below a particular price, it should automatically sell it. So in this case, the trading system is continuously processing the stream of the price of that stock and then examining it so that it can execute the trade according to the user specified rules, right? Similarly, like in a factory or in a machine, if you want to identify any problem, then you would be continuously monitoring the state of your machine, right? And you will be continuously monitoring that stream of data. And similarly, in military and intelligence, you might be tracking activities of various metrics that you have, and then you would be raising alarms if you see that it's a sign of attack, right? So, uh, so this, right, monitoring is one of the uses of stream processing, and I think it's not mentioned in the book, but like if you have your service running, then you are continuously monitoring your service for particular metrics, and then again you're monitoring and creating alerts if you see that your metric is not behaving as it should be behaving, then you will create alerts. So in this also, you are continuously monitoring your stream data and then creating alert on top of it, right? So that's monitoring, right? Uh, the other use of stream processing is complex event processing. So basically, what it means is that you are searching for a certain event pattern in the stream of data, right? And it is similar to like that regular expression match. So basically, you write a high level declarative SQL, like in a high level declarative SQL like a language, you write a query, and that query describes that what kind of pattern should be detected. And then uh, your stream processing system will be continuously processing the streams, and it will be looking for that pattern, the pattern which you have uh, saved. And if that pattern matches in that particular stream, then it will notify you that this is the event that has matched, right? And the interesting thing about it is uh, the relationship between your actual data and the queries that you execute has reversed here, right? So in a normal database, you store the data. Data is the permanent thing, and your queries are temporary, right? So you will execute your query when a user gives the query, and then you're done with the query, right? But here you are storing the query. The query is whatever kind event pattern that you're looking for. So that is stored permanently, and your data is that events which you are receiving, those are temporary. So those events are matched for that query pattern. If they are matched, then the user is notified, right? So again, one more use of this complex one more use of stream processing, that how you would be using your streams, right? The third use of stream processing is stream analytics. So basically, you are so stream analytics is you are doing some aggregations or creating some statistical metrics over large number of events, right? And so, for example, you are measuring the rate of some type of event, that in a particular event, in a particular interval, how often that event occurs, right? So that will give you the rate of that event. Or let's say you are calculating the average of a value over some particular time, right? And Or basically, the third example is that you're comparing the current statistics to the previous statistics. So this could be useful. For example, if you have a service running and you have some previous statistics about how your service behaves. For example, so you have some volume of users using your service, right? So that is your previous data. And now let's say you see a huge spike in the usage of your application, then that is something that you should be alerted about because you need to see what's happening, right? So these kind of things where you are comparing your current statistics with the previous statistics, right? Or let's say you have some volume of users that you have seen in the past, and now suddenly you see a big drop in the usage of your application. So what happened? Maybe some of your service stopped responding or something happened because of which users are making requests, but they are not reaching your service, right? And that's why you have seen a big drop in the usage of your service, right? That could be one of the reasons. So these kind of things needs to be alerted on, that whenever you see a huge variation of the use of the current statistics of your service from the previous one, right? uh, so basically, in these systems, when you're building these kind of systems, you are computing your statistics over a fixed time interval, right? Like, let's say you are taking average number of queries over a 5 minutes of time, right? And then over 5 minutes of time, you can calculate average, and you can calculate the response time, that what is the 99th percentile of the response time, right? Uh, so then the next use of stream processing is maintaining materialized view. So what this means is uh, like, so you have, again, this is similar to what we have discussed in this buildings secondary storage systems, where you have some derived data system, right? You have cache, search index, or data warehouse, and you want to keep that system up to date with the source database, right? So these uh, derived data systems, this could be considered as materialized view, right? So does anyone want to tell what is the meaning of materialized view? This term has come up a lot of times in this book. Hope my speakers. Okay, yeah. So basically, yeah, let's see the meaning of materialized view. So let's say you have some source data, right? Your original source data is the source of truth. So for example, your user profile information, where you store that user table, that this is his name and all those details, right? This is your source of data. And you now you see that, let's say you are doing lot of queries where you are searching for users living in a particular location, right? So what you are doing is you have created a denormalized table where you are storing that for each location how many users are there, so that every time if you want to do that query, you don't need to do that aggregation again and again. You are denormalizing and keeping that information with you, right? So that you can quickly query that information. So that is, you have created a materialized view. So materialized view is that whatever original source of data you had, you created another view out of it, and that view is kind of a denormalized way of your data, which is frequently used by you. So to save your time, to make your query faster, you have created a materialized view out of it, right? So all these derived data systems, these can be considered as materialized views. So how their materialized views is that you have some original data, right? And you don't, if you every time if you have a query on that data, if you directly perform that query, it will be slow. You need to do some computation. So you pre-compute that computation and store them in materialized view. And that is basically also like derived data system. So your cache, right? Your cache is you're storing that information in a cache which is repeatedly queried by you, so that you don't have to do that again. Or search index, right? So you have your documents which are source of truth stored somewhere, and now you have built a secondary storage system which is a search index out of your original documents. So now whenever you want to perform the search, you will be using your secondary storage system which is search index, which is can efficiently perform the search, right? Because it has indexed your documents, and it is a derived data system, right? So now all these derived data systems that you have made, you also need to keep them up to date. Coming back to my first example, so you had a users table where each user and his location, his user profile was stored in a table. Then you have created another table denormalized where for each location, how many users are there, right? Now, if a new user is added to your original database, your secondary table also needs to be updated, right? Because for that particular location, one more user has been added. So you need to update your these derived data system or materialized view, right? So that's again for these things you use stream processing, because when you get a, so basically whenever any change is made to the original data source, a stream of event is generated, and that stream of event is processed to update your materialized view, right? uh, so this was uh, yeah, so this was keeping your derived data system up to date. Then the second thing is event sourcing. Basically, event sourcing is so your application state is determined by a log of events, right? So in event sourcing, you are storing the logs of events. Each log that happened, you are storing it, and that complete log of events determine the application state, right? So here, like when you have to create your application, you need like whenever you need to retrieve your application state, you need all all the logs back in time, right? uh, so and one of the things which is mentioned here is, so these materialized view, how do they differ from stream analytics? So basically in materialized views, you are maintaining your events forever, whereas analytics framework operate on a window of limited duration, right? So let's talk about this more. So basically, these materialized views, right? They are your secondary derived data system. So they need to maintain all the events to give you a true picture of how your secondary data system is, right? Like if you are building a search index and uh, of documents, you cannot just keep the recent updates that happen to your document in your derived data system, right? You have to keep all the events that have happened from the beginning of time, because that only represents the true picture of your search index, right? Whereas whenever you were using stream analytics, then you don't worry about, you don't too much worry about the beginning of the time. You are just taking the events in some particular time window, right? So, for example, let's say if you were comparing your current statistics to the previous time interval, so probably you would be taking uh, your usage statistics of 1 week back, that in 1 week back how my application has been used and how my application is being used in this hour. Has the usage spiked or dropped compared to like last 1 week of data? So only that 1 week of data is sufficient, right? You don't need to store that you don't need to keep that uh, entire history of events, right? So this is a major difference between stream analytics and maintaining materialized view. Any questions so far? Okay. Uh, so now another use of event processing is search on streams. So this is very similar to what we discussed, complex event processing, where you are uh, writing some declarative query and you are looking for some particular pattern in your events. So similarly, uh, basically, you are so like let's look an example. With example, it will be more clear. So let's say like sometimes uh, when you are regularly reading to news feed, right? And let's say you are uh, very much interested in some particular subject. For example, let's say you are very much interested in distributed systems. So basically, you have added an alert to your this news processing service that whenever any new news or any new paper you get related to distributed systems, it should alert you, right? So here again, whatever your search query is, your search query is distributed system that is stored in your system. And whenever now new news articles or new research papers are published, they are matched again the search query which has been stored. And if they match the search query which has been stored, then you will be notified, right? So again, this is one more use of stream processing where you are doing a search on a regular source of streams, right? And again, it is different from conventional search index because here uh, in the conventional search index, your documents are indexed and then your search query is run on those documents. Whereas here, your search query is stored permanently in the database and the stream of documents are then matched against that query, right? Very similar to what we discussed in complex event processing. So yeah, so basically we have seen like various uses of how stream processing is useful, right? Uh, so now, like now, when we are making the use of this stream processing, one of the issues that we will face is reasoning about time. And so now I will briefly go over that how reasoning over time could be difficult in stream processing, what are the various challenges that we will see, and then how we can go about fixing those challenges, right? Uh, so like first to like show what the problem with stream processing is. So in batch processing, uh, we can always use the timestamp of the event, and basically that represents our time and the things are simpler, right? But in stream processing, uh, like when we are dealing with streams for analytical purposes, then we will see that using the timestamp of events might create some problems, right? And so a lot of these stream processing frameworks, they don't use the timestamp of event. but instead they will use the timestamp of the local time on the processing machine. So let's say in your analytical query, you are saying that look back for events in 5 minutes window, right? So that 5 minutes window, what that 5 minute window is it the 5 minute window of when the events were generated, the event timestamp, or is it the 5 minute window of when your this processing engine is running, the timestamp of that processing engine's machine? Uh, yeah, right. So it could be either of those, right? So the advantage of using the timestamp of processing machine is it makes the process simpler. Uh, and why it's simpler, we'll go in the detail of that. But at least one thing we can say is that it has a disadvantage. That disadvantage of using the local time of processing machine is that if there is a significant delay between the event time and the processing machine's time, so basically then if you're saying that look back for events in previous 5 minutes window, then uh, basically that 5 minute window might represent times of some particular other interval because your actual source events had a huge delay, right? So like the alert or something which you're getting might not be what you're expecting because your events have been delayed, right? uh, so like here is a good example of this. So first, why the processing of events could be delayed? It could be delayed because of network faults, queues, or perf issues, right? So when this kind of thing happens, so what could be the issue? So let's say you have a web server which was generating some events, right? And this web server has its own timestamp of events. And then this is your stream processor, and this is another machine. It has its own local time, right? So now let's say what you were doing was you were measuring the average. Uh, let's say you were making a count that how many count of uh, of these events you are getting every minute, right? So then your stream processor would be running and it will be taking the count of events. So it will be running, and then let's say at some particular time it stopped, right? So then when it restarts, it has to process, it will be processing all these events which it has not processed from the web server when it restarted. And so at this particular moment, it will see a spike of events, right? So here the events were constant. When it restarted, we will see that there are no events. And when it came back again, we will see a spike of events. So this is the problem because we are using the timestamp of this stream processor that at this particular time interval, how many events this stream processor uh, received, right? Uh, if we would have used the timestamp of web server, then we would not have faced this problem because then we could see that the events of this web server did not happen at this time interval. They happened like long before. So then we could have made a better use of the data, right? So we saw like what is the problem with using the timestamp of your stream processor machine, right? Now let's see what is the problem if we use the web, this your source events timestamp, right? Here it will be web server. So the problem that will come is you would not know when you are ready. So what we mean to say by that is that basically you do not know that when the web server has send you all the events for that particular time interval. So let's say if you are saying that I want to look back uh, all the events between 7 a.m. to 8 a.m., right? All the events who have the timestamp from the web server from 7 a.m. to 8 a.m. then and your stream processor is waiting for the events, right? So you don't know, like probably some events are lagging your server, they are stuck in a queue or something, and you have still not received those events, and maybe sometime later you will receive those events, right? So so problem with using event time is you can never be sure when you have received all events for that particular window. So how you can now, this is the problem, how will you deal with this problem? So you could do two things with the straggler events, right? Either you can ignore those events. So you are making the assumption that these kind of events which are straggling will not be very high, they will be a very low number which does not affect your overall data, right? Because you are like, with the law of large numbers, maybe that number is so small that it will not affect. And or you can keep a track of that number, and if that number is greater than a particular threshold, then you create an alert that, hey, a lot of events have been straggling, so just see the health of your service, what's happening, and maybe it's time to redesign your service or do something else, right? Or the other thing you could do is you could publish a correction. So then whenever a straggler event is arrived, then for that uh, particular window, you will send an updated value that, let's say you were, uh, your metric was count. So now you will send the updated value of count for that window, that between 7 to 8 a.m. you have not received 50 events, but you have received 52 events. So you will send that update, uh, and that's another thing, right? So these are the two things you can do when
So
you're facing the problem.
when you are using the event time,
Mhm.
why are we not sure what is the particular window at the server?
No, we are sure. So the stream processor, it is saying that I want to calculate the count of all the events that happened in a window between 7 to 8 a.m., right? So now it is waiting for the events from web server. Web server will be sending the events. So some events will be at 7:05, 7:10, 7:15, and it is taking the count of all the events, right? And now let's say now you have moved forward, now you are at 9 a.m interval, and now at 9 a.m when you have uh, already sent the data of this is the total count between 7 to 8 a.m, now your web server says, hey, one of the events which happened at 7:15 a.m timestamp, I missed that, it was stuck in a queue, and there is one more event that happened, right? So now you have already created the aggregate value. So what you would do that with that event. So that is the straggler event.
Okay.
Uh, okay, so now the next thing is whose clock are we using? And this is one another interesting problem that we can will see. So this is the problem that, so I'm again and again saying that uh, the the timestamp of the event is 7:57, right? So how have you calculated that the event of the that the timestamp of event is this, right? So 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 like let's see some of the problem here. So let's say you have a mobile app, right? That mobile app is logging uh, the user's usage events to a server, right? So in my mobile app, I'm using the app. So whenever I click on something, it is sending that event to the server, right? That at this particular event, at this particular timestamp, this event happened, right? So now when my mobile app becomes offline, then uh, then basically I cannot upload any data to the server, right? But still I'm doing interactions with the app. So basically, that app would be locally storing that data in a buffer, and whenever my app becomes online again, it will be sending those buffer of events to the uh, to my server, right? That these are the events happened when the app was offline, right? User made these interactions. So now in this, if to basically find the timestamp of the event, if I'm using my mobile's local timestamp, then the problem is my mobile's local timestamp could be incorrect, right? And so uh, so so if my local timestamp is incorrect, I could be sending events with wrong timestamp to the server, right? And I'm saying I cannot directly use the timestamp of the server of the server itself, because my app can go offline. So in case if my app is going offline, then I cannot contact this internet, right? So I don't know at what timestamp the event happened. So then I have to use my mobile's local timestamp, right? So how do we deal with this problem? So does anyone know that how we can deal with this problem? There is a way to deal with this problem. I think this could be one good interview question. Or does everyone understand the problem? What is the problem? Or if you want, I can repeat the problem.
Yeah, can you repeat it, please?
Okay, so yeah, so let's repeat it. So basically the question is that I have a mobile app, right? And whatever user interactions a user is making in the mobile app, I want to log all those interactions. So in the log, what will you store? You will store that at this timestamp, this event happened. So at this timestamp, user clicked on accounts overview. At this timestamp, user clicked on make a transfer, right? Maybe a mobile banking app is storing all these interactions, right? So now, how will, when you are storing this timestamp, what is the value of the timestamp? Will you be using your mobile's clock, whatever is your mobile clock, that will be your timestamp? Or will that timestamp will be some internet timestamp, which is a server, your like whenever it is connected to the server, that timestamp? What will you use?
Can we ask server to provide correct timestamp? Yeah,
Yeah, so you can do that, but I'm saying that I want to make my application usable offline as well. So if I'm using my app offline as well, then I cannot contact the server. And now when my app is offline, someone can change my mobile's timestamp. So whatever last correction that you made with the server, that could have been modified by the user. The modified user could have changed your local mobile time, and so then you would be facing this problem, right? If
in
your app is always off online, then you won't have a problem. But if I'm saying I want to provide offline also, and I want to store all the interactions of offline usage as well, then I'm in trouble, right?
yeah, we can use logical timestamp or logical clock. I think it's one of option to discuss. Yeah, we can have some logical clock like I don't know, like port clock or something like this.
But with logical clock, how will you do the stream analytics? So basically, with stream analytics, we are saying that at particular time interval between 7 a.m. to 8 a.m., how many users were using my app, what feature they were using the most. So maybe if I have a shopping application or something, right? And I want to see what, uh, yeah, I mean, we want to see what was the most viewed feature of my application or something like that at what particular time, then these logical timestamps don't have that meaning, right? So you need actually physical, the actual physical timestamp.
But when you say offline, you want to keep the record of it offline.
Mhm.
If suppose it's a shopping application, then we cannot use it offline. We have to connect to the server to do those
Yeah.
transactions.
Yeah,
So
maybe shopping app is not a great example then, but
yeah, shopping
let's
is
say,
not a good example, but if you're using a Windows computer, right, and it is not connected to internet, but you have some apps, applications, and when you want to send the application, like when the Windows crashed, or some you send the
Ha
report
ha
or
ha
something.
ha ha ha. Ha. I think
So
there is a
next time when your
universal
computer
time
is on,
conversion. So where which can be UTC, I think, where all the events can be logged in that timestamp
yeah,
and
they
then
can use
converted back.
UTC, GMT, or time offset between, and whatever is the local time versus offset. So if you're using PST versus EST or IST, then you'll always have a
no,
time
no.
offset. I don't it, I
So
don't know which
okay, so
one.
these are two. Yeah, so these are two. So okay, so let's go into this UTC thing. So basically, my this laptop's timestamp, right? I can set it to anything. I can set it to anything, and then so right now I'm in IST, right? And basically, if I want to get the UTC value, then there is a conversion that it's a fixed conversion that IST to UTC, you add this much value and then you get a UTC time zone, right? So that does not mean that whatever timestamp I'm setting, it will be always correct if it is a UTC time zone. It is just a time zone. So I can very much set a wrong timestamp in UTC time zone. I can change my time here to, like, right now in IST, let's say it's 10 p.m., right? I can make it 10 a.m. And then the UTC value will also be incorrect because it is just fixed value. So then whatever logs my machine will be sending, if it is offline, so it will be my machine will be storing the logs locally, and when it becomes online again, it will be sending them to the server. So then whatever logs my machine has generated, they will be incorrect because I have set wrong time on my machine, right?
You can
So
maintain
mhm,
you can maintain
How do we?
last.
Mhm.
yeah, anyone can go ahead.
I had this. I was just wondering, like, how is NTP utilized here? Because for time synchronization, we use that.
Yeah,
Uh, so I was thinking if I mean it is even relevant to think about NTP here.
yeah, you are right. Like NTP, if your app is online, it can connect to NTP and get the right time, right? So
Hmm.
then even if I have set incorrect time, then it can get the right time. Then, but you have to think about one thing. Then every time you are logging something, first you will contact NTP because you are saying that I cannot rely on this user's machine. So then every time you have to log anything, you are making one additional request to get a NTP time, which is such an additional overhead. You were
Hmm.
just storing the logs, and for storing the log itself, every time you have to make a network call, right? So that is another problem which you, and then let's say you are saying that you will sync only once every day with NTP, so to reduce that overhead, then what happens if a user has changed his time uh, in between that? So basically you're saying that you will sync your app once with NTP, and whatever is the difference between NTP and local time, you will store that value so that you know what's the right value, how much offset users local time is with the NTP. But then the thing is, then the user can again change his time, and then that offset might become incorrect after some time, right?
Hmm.
So yes, someone was proposing some solution. Uh, okay, so yeah, let's see that one of the ways. And this also could have some problems. We'll discuss that. But see, so one of the ways we can do it. Uh, so basically, we will log three timestamps. So time at which event occurred according to my device clock, even if it's incorrect, whatever my local time is, I will log that event, right? Then I will also log the time at which the event was sent to the server according to my local machine time, which could be incorrect again, right? And then when the event is received by server, uh, I will keep a track of what is the time at my server clock. And basically the difference between the server clock's time versus the device clock times is my offset, right? So basically, I am sending an event, let's say at 10 p.m. IST, but at the server when the event was received, it is actually 10:05 p.m. IST. Then I know that this user's machine was incorrect by 5 minutes, right? So then, whatever timestamp of event he has sent me, I will adjust that offset from from that event. So then I will get the right value. But this has some assumption. One assumption is that the network delay is negligible. So that means that basically you are syncing between 2 and 3, right? So you are saying the local time of your machine versus server time, they determine that what is the offset. So in that process, you are not considering the network delay. So one of the things is this. And another thing is that whenever uh, whenever this event was recorded, and just after and between 1 and 2, if the user makes a change to his clock again, then also it will send an incorrect value, right?
So uh, we could do it in at the client level as well, right? I mean, mm, I'm just
Yeah.
guessing. So you could whenever an event happened, I mean, you could actually check the last, whenever the client was online, you can actually maintain the local server time and local device time. And whenever an event happened, you can actually check the duration between this last online time and this one. You can last online time plus duration between these two events. I mean, maybe we could. I'm just thinking like that.
Yeah, I mean, like, you are thinking of some algorithm to make the correction, and yeah, that could be, yeah, I, whatever algorithm that could be, this is the one of the algorithms. But yeah, there could be other algorithms as well to make the correction. So
Or one other thing that I'm thinking is on the client itself, like keep on checking what is the device timestamp, whatever
mhm,
that app is supposed to send us. And if we are offline, the clock will drift at a constant rate, right? But when we connect to online, if we have at that time, the clock may go forward or backward significantly if we are drifting a lot, right? So
mhm.
what I am thinking is keep constantly checking, has the time changed or not. I mean,
Mhm.
significantly, if we are like keep checking every second, like I am expecting the right now the time is 10:107. Is the time 10:107? If not, and if it has moved like 10:150, it means we have jumped forward these many seconds. So add that as a drift or plus
Mhm.
or minus, and then when we send events, just do that plus or minus and send all those.
Yeah, yeah, exactly. I think, if I'm not wrong, that was the exact algorithm that I was also saying. Yeah, that whatever is the change that have happened between the local time and the server time, that is the offset, right? And so basically you are making that adjustment of that offset from all the events that have happened during that interval.
So here you take three timestamps: the one at
Mhm.
which event occurred, the one at which event was sent, and the one at which event was received. But we
Mhm.
take into consideration that delay between sent and received. We
Yeah,
just take
we
offset between occurred and received.
no, we are so if we ignore the network delay, then we are the offset is uh, the time which was the server clock's time when the event was received, right? Because now the event has been received by server, so you can take server clock's time. And the time when the event was sent by my machine, then it is my local machine time. So whatever is my local machine time when I have sent the event, and whatever is the server times when it has received it, that is the offset, right? Because that tells me that server clock time says this and the device clock time says this.
Okay.
So that is telling me the offset, that the device clock is offset by that much amount from server clock. So basically, like think of this. So when you're syncing your clock from NTP, what will you be doing? That you will be saying that you will be sending a request to NTP. You will be saying that this is the local time that I think it is. And then NTP will be saying that, no, this is the actual time. So then you will be, whatever is the offset, like whatever the NTP sent you and whatever was your local time, that is the offset. And that you will make as an adjustment to your local machine's time to know what is the correct time, right? So similar thing we are doing here. And like I think in previous chapters when we discussed about synchronizing your time with NTP, there also we discussed that one of the problems with synchronizing with NTPs, that network delay, like the the network delay is not accounted in synchronization with NTP, because now NTP said that this is the time, but when you received that NTP time, that had some delay, and then you have that incorrectness factor uh, with that. So that is something that you have to deal with the network delay, and like you have to assume that network delay is negligible over there.
So by the time between event happened and event was sent to the server, I mean user can mess with the time, right?
Yeah, if you are changing your time clock between 1 and 2, then you will get
Yeah.
incorrect information. Yeah, then you will get incorrect information. That yeah. So again, this is not foolproof. This is one of the way. Yeah. Yeah, but like assuming that your app, basically this is the time when your app was offline. So assuming that your app was not offline for a long time, and in that duration someone has not changed the time, then you can deal with this problem. Okay, so let's move on to this next topic of, so all so previously we have discussed about various type of windows, right, that we will be using for aggregations. So what are the various types of windows that we use? And basically you will see these terms used a lot whenever you are creating your monitoring and alerting services, that what kind of windows you want to consider, right? So here are these four terms. So let me explain one by one. So first is a tumbling window. So the meaning of tumbling window is that you are taking a fixed length window which is non-overlapping. So that means that every event will belong to exactly one window. Like if I open Paint, uh, so basically a tumbling window interval would be like this. So between like 1 to 5 time interval, then between 6 to 10, then between 11 to 15, right? So this is like basically non-overlapping fixed length interval. So this is tumbling window. The second is hopping window. So hopping window is again fixed length, but it allows some overlap to provide smoothing, right? So your hopping window, so let's say you have a 5 minute window with a hop size of 1 minute. So your window is of length 5, right? 1 to 5, and your hop size is of 1 minute. So you are saying that the next window will hop by 1 minute. So now this next window will start from 2 to 6, right? Then you will again hop by 1 minute. So next window will start from 3 to 7. So this is your hopping. The third thing is sliding window. So sliding window is that basically you are taking all events that occur within that interval of each other, whatever interval you have defined, all events that occur within that interval. So, like example of uh, hopping window would be that let's say you have defined an interval of 5 minutes, then all these events that happened in last 5 minutes will be taken. Then your window will be slided by maybe 1 second or something. So now when a new event arrives, this last event will be taken out from your sliding window, and then this new event will be taken. Then when you get your time increases by 1 more second, then again you take remove the last event of that 1 second which you had, and now you take the new event, right? So this is a sliding window. So it is implemented by taking a buffer of all the events that are sorted and that occur within that window of interval, and then you keep on removing the old event as it expires from the window, and you keep on adding the new event as your time window shifts, right? Then the fourth is session window. Session window is like uh, it is not a fixed duration in window. It is just that for a particular user's session, all the events that happened, you will take them part as of one window, right? So that is session, right? So these are the four types of
What is the
windows.
use case for hopping window?
What is the what
Use
use
case
case?
for hopping window?
Yeah, that's a good question. I have not used hopping window. Has anyone used hopping window? I have used sliding or tumbling.
That's all right. That's all right. I just had a, I mean, I was curious if anyone knows.
Yeah, no, yeah. Thanks for the question. Yeah, I was waiting if someone has any answer. Yeah, but I don't. Okay.
Okay.
Yeah. So then these are the types of windows. So now the next discussion that we will do is stream joints. It is a like a little interesting concept and not very trivial. So let's see if we are able to do it in 15 minutes, maybe. Yeah, let's see. Okay, so basically we saw in batch processing, if you people were in batch processing, that you need to do some joins, right? Or if you have experience in batch processing, then you need to join data from various sources, right? So similarly, in stream processing also, you will have various scenarios where like you generate stream of events different stream of events, and then you want to join the data from those various streams, right? So how do we do those joins? And uh, since now events can appear at any time, so basically in batch jobs you have that fixed data set. So now you have that fixed data set, now you can do a join, right? So think of it as a like batch join could be considered as a table. Like table has maybe a smaller amount of data, batch jobs have very large amount of data which could not fit on a single machine. It is distributed among multiple machines, but it is fixed amount of data. So on that fixed amount of data you can do the join, but in stream you don't have that fixed amount of data. So how do you do the joins, right? So this is our next topic of discussion. So generally we will do three types of join in streams, which is stream joins, stream table joins, and table joins. So yeah, like at first it seems like this third one seems out of context, right? How table joins is related to stream. How is it related to stream? So when we will go here, then we'll try to understand why it is part of stream. Okay, so let's start with stream joins. Uh, so and how it is explained in the book is through an example. So I'll also try to uh, go through that example. So let's say you want to uh, so basically let's say on your website you have a search bar, right? So whenever someone searches for something, then you provide him some links, and then the user clicks on those links. So now you want to detect that for a particular search, what URL is clicked, what is the trend over there, that for this particular search, people usually click on this link, right? So you want to see that relation. So how will you do that? So now in this system, when you are building this kind of system, you have two event sources. One event is that every time someone types a search query, you generate an event that for this session ID, this search query was performed, right? And these were the results returned. The second event that you will generate is when someone clicks on any of those search results. So then you will log another event saying that the user has clicked on this search result, right? And uh, so now so few things. One thing is that there could be significant delays between the first event and the second event, right? So you would have searched for something, you may not have immediately clicked on the search result. Maybe you went to some other tab, you forgot about it, and then you came back to it, and after 5 minutes you clicked on the search result. So that is one thing, right? uh, so uh, so now like how do we actually do our data analysis of for a particular search, what uh, URL are users clicking on, right? So so let's see how we will implement that. So for this we would need stream join. So and we will be joining these streams by session ID. One stream is this of search query, another stream is of user click, and we will be joining them by session ID and then getting the aggregate, right? So before we go there, there is one question. The question is, why do we have to join these two events? Why can't, when the user clicks on the search result, right? So during the click, we can also log that he performed the click on this search query. And then we know that for this search query, user has clicked on this search result, right? So then we don't need to do any join. So basically, uh, so let me explain the diagram. So let's say on uh, my search query is SD skills, right? And this is my search results, 1, 2, 3, right? So I'm saying that basically in my web page, I have this information that the search query was SD skills. These are the search results. So whenever user clicks on this second event, right? Uh, Whenever user clicks on this second uh, search result, at that time I can log that this was the URL and this was the query, right? So I can just log one event, and then I can tell that this link was clicked for this search query. So then I don't need to do a join on these two events, right? But what is mentioned in the book is, yes, you can do that, but then you will not know. So you, in this way, you can capture all the scenarios when the user clicked on one of the results for your search query, but you cannot capture when the user performed the search but did not click on any of the search results, right? That is something you will not be able to capture because you're only capturing the event when the user has clicked on the search result.
And also there might be the another use of you capturing the queries like for finding out trending or something. So
Yeah, I mean, yeah, that is another, yeah. Okay, so now we have, so now we understand that why we need to track them separately and need to join. So let's see how we will do the join. So the way to do the join is, so basically you will maintain a state. So the stream processor will say that I will only keep track of all the events that happened in last 1 hour. And yeah, if they are past 1 hour, then I will not track them. So now when a search event is performed, right, then it is added to that index that for this session ID, this search query was performed. And whenever a click is performed, then again we will also like store that in an index. And then when for particular search query we find a matching user click on a URL, then we can join them, right? And say that this for this user query, user clicked on this search. And for a particular user search query, if we don't find any click event, URL click event in past 1 hour, then we can say that for this user search query, there were no clicks, right? So now we have both kind of data. When the user clicked on one of the results of the search query and when the user did not click on one of the search query results. So, right? So if the search event expires without any click event, you emit an event saying uh, which that these search results were not clicked, right? So this is an example of stream join that you produced two streams and you're doing a join on them. The next type of join is stream table join. So a stream table join is that you have some activity of events, right? So let's say you have some user activity, and then you also, so now whenever you have some user activity, you will be storing those events with the user ID, right? But the user profile will be stored in a separate table, right? And now when you want to, let's say, display that information somewhere, then probably you would need to join that with the user profile table, right? So basically user profile is now here your table, and user activity is the stream of events, right? And you are joining them. So basically this is also called your enriching your activity event with information from database, right? So now to do this join, there are two ways. One way is that for that user ID, you make a remote call to the database which has the user profile, and then for that user ID you find all the information for that user and join it and then return it, right? But remote calls would be expensive. So the another way is that your stream processor is keeping a local copy of the user profile database with it, and whenever a stream event comes, it looks up locally in the copy of the user profile data and joins it, right? So that is another thing you can do to optimize rather than making a remote call. But then if you are having a local copy, then the problem is that your local copy needs to be updated, right? Because that user table could have got updates, right? Maybe you have added new users and things like that. So you need to update your user table. So that is also something you can do by basically your stream processor is now also uh, looking for the updates to the user table. So it has also subscribed to the stream of events which represent the changes to the user table. And whenever those events occur, it will update the user profile database, right? And now, if you think about it, it is again then similar to stream processing, because stream join, basically you have a stream of user activity, and also you are also listening to the stream of user profile changes, right? But why we are referring one as stream and one as table, the difference is the table, it has the entire history of data. So the user profile, it has all the events, it has to store all the events, it has to store the entire data base table of user profiles, right? Whereas user activity is actually just a stream that it just needs to keep the latest user activity that happened, right? Like it does not need to know the all the previous history of user activity to make any meaningful uh, to like to get any meaningful information, right? So yeah, so now if if you people understand it, that basically table is also here a stream of events, right? But only difference is that table, why is it a table, is it has the entire history of all the changes. Then it is easy to understand table joins. So how table join fits in stream joins is because these tables are also created from streams of data, right? The only thing is that these are called tables because they store the entire history of all the events. So now the table join was explained by Twitter example. Yeah, I don't know if we have enough time for it, uh, but yeah, I think we have only 3 minutes. So yeah, let's try to finish this so that at least we have finished this topic. So table join was explained by Twitter example. So let's say you have a user's timeline and you want to, so basically in Twitter you want to show a user's timeline, right? So now to display a user's timeline, you would have to go through all of his uh, following, whoever the user is following. You have to pull up their top recent tweets and then do a join on them, and then you will get a user's timeline, right? And if you do that, it will be expensive. Your experience of Twitter will become very slow. So rather than that, you would want to have your timeline cached. That means you would want to pre-calculate that for this user, this is the timeline. So that whenever if user wants to see his timeline, you don't have to do all these joins and all, and you can quickly get the data. So how would you do that? So basically, uh, what you would be doing is that you will be materializing and maintaining this cache information with you, right? And if you think what we have discussed in the past, materializing was also like keeping all the streams with you and not missing any stream, right? So so basically this is the information you have to store, that whenever a user sends or deletes a new tweet, all of his for all of the people who are following him in their
Abhishek,
time.
do you want
Yeah,
to wrap up? Because it's almost 9. So
yeah, I was thinking that this topic will be interrupted in between, so is it okay if I take 3-4 minutes?
Yeah, it's
uh,
fine. Oh,
yeah, yeah, I mean, like we'll be starting the session. I think folks will be joining and they may get confused. So
Okay, they might get
if
confused.
possible,
Okay,
yeah, try to repeat this topic in the next session, if possible.
okay,
Like
sure,
if,
sure. Yeah, okay. Okay, so yeah, let's do this topic next time then. Yeah, so that's it. Okay, thank you, everyone.
can you make one of us the host, Abhishek, myself or Ashim?
So Abhishek, in the